Hi everybody, thanks for being here. I'm Sébastien Deleuze. I'm working at Broadcom as a Spring Framework core committer. I'm involved in the Kotlin support, but also I'm working on some cross-cutting topics like Null Safety in the Spring API with JSpecify. I recently introduced the Jackson Free support, which will be available in Spring Framework 7. Working on runtime efficiency stuff with GraalVM, Project Leiden, etc. But today we are going to focus on Kotlin, and more specifically, the next level Kotlin support that we will introduce is Spring Boot 4. I have been working on Spring team for 10 years now, and I've been introducing the first Kotlin support in Spring Framework 5 in 2017, so quite a long time ago. Since a lot of big companies are now using Kotlin, I think Spring is the most popular web framework on Kotlin side. And we see a lot of developers using Kotlin, but I think we can do more and increase the market share of Kotlin within Spring application and provide an even better developer experience. So this is why today in the keynote there has been an announcement which is the next major step. We are starting a more strategic partnership between JetBrains and Spring team in order to basically increase and improve the developer experience that we provide. Until now, it was quite an organic collaboration, and now it will be more people from the Spring team collaborating with more people from JetBrains. We have some bi-weekly meetings, and we are trying to invest more into improving stuff. So most of those improvements will be available in Spring Boot 4, which will be released in November this year. So the baseline for Spring Boot 4 will be Kotlin 2.2. That will be the minimal version. That way, the dependency management will be available by default with Kotlin plugin version that will be compatible. Right now, you can already use Kotlin 2 with Spring Boot 3, just dependency management is not the right one for Kotlin 2. We are not testing everything, so that will be a first-class support. And any Spring Boot 4 application will use Kotlin 2.2 as a baseline. It will be based on Spring Framework 7, which is going to provide a lot of Kotlin-related features. And we are going to detail today a bit what are those new features. The first thing is the Null Safety of Spring API. So Null Safety is not new. We have been introducing that in Spring Framework 5. But we are going to reach a new level by leveraging JSpecify annotation. So you may have seen potentially this on social media. I shared that I merged the biggest commit ever on Spring Framework code base when I migrated from GSR 305 based annotation to JSpecify, which is a new standard. We have been collaborating with JetBrains, with Google, and with other companies in order to standardize null safety annotation on Java side. And one of the goals was to provide better Kotlin API, more idiomatic Kotlin API, by providing basically a simple dependency, what we can use, proper semantics, proper specification, and this is what JSpecify is about. I think it took 5 years to reach 1.0, so quite a lot of work, mostly on specification, because this is just 4 annotations. And now Spring Framework 7 is going to use that in order to provide null safety everywhere, and also including on generic types, varargs, elements, etc. So the scope is wider than what we had with GSR 305, and this is a properly supported dependency. So in practice, what we have done is that in the Spring Framework code base, we have annotated every package with @nullmark, which says basically the default is non-nullable, and if you have something nullable, you need to express it with explicit @nullable annotation. And in the code base, like here in the cache API, we are basically annotating only what is nullable, and that way, instead of having some platform types where basically the nullness is unknown and you can add null pointer exception and it does not feel very idiomatic from a Kotlin point of view, you get full null safety, including on generic types, etc. So we already had pretty good null safety on Spring Framework side, but there is 2 changes. The first one is that by default, as of Kotlin 2.1, Kotlin interprets mismatch of nullability with JSpecify notation as errors, like if it was written natively with Kotlin. So you don't need anymore some customization of your compilation. It's basically like Kotlin behavior by default. But the biggest change is the following. We are not going to only annotate Spring Framework and a bit Spring data like until now. we are working currently on annotating every Spring project. So right now, the Spring team are super busy annotating and introducing Null AI plugin to check Null Safety, because it's just not about annotating, it's also about checking that everything is consistent. We are annotating, or we are going to annotate Spring Boot 4, Spring Framework 7, Spring Data, Spring Security, Spring AI, etc. All the major Spring frameworks, Spring projects and libraries are going to be null safe and provide a null safe API to Kotlin programs. And I think this is really a game changer to basically remove null pointer exception from production. It's not just about just Spring Framework, the scope is wider. The other new feature is the new bin registration DSL. There was until now a bin definition DSL that was provided, but the integration in Spring Boot was not super nice. It was not possible to support Spring IoT, and there was various limitations. So it was not really a proper foundation. So the new bin registrar DSL that we are going to introduce will feel very natural for people used to using the bin definition DSL. The syntax is very close, but it's based on more solid foundations. It's going to extend a new bin registrar Java API, while the former was just extending a very low-level application context initializer contract. And that will allow to provide first-class support on Spring Framework side, and you are going to be able to leverage that on in your Spring Boot application. There is full support for Spring IoT, so if you are using both the DSL to define bins and Spring IoT to get the optimization at runtime, it's possible, while previously it was impossible. And there is seamless integration with Spring Boot and add configuration classes, meaning that you can also use that in libraries with automatic discoverability. In practice, and I'm going to show a bit of Java code, this is the bin registrar Java contract that we are going to extend with the Kotlin support. It's a bin registry that allows to register bins. So in Java, it's a bit verbose because there is less DSL and reified support than we have on Kotlin side. But the key point is that we are going to use a contract that the core of Spring understands perfectly. It's not just a low-level application context initializer. And so what it will allow to do also on Java side, it's to build any kind of DSL specific to your business, or for example, if it's not the case yet, but if Spring Security decide to begin building a DSL, it could use this bin registrar thing, and that can allow you to build any kind of custom DSL, including for Java use case. And what we are going to do in Kotlin is that we are introducing a bin registrar DSL, which is basically implementing this bin registrar contract, and that allows you to write your bins in a functional way with for loops, if statement, profiles, etc. So pretty close to what we had, but again, it's more integrated into Spring Boot. So while previously you had to provide an application context initializer, now you can just use @import with basically your DSL defining bins, and that will be taken into account automatically. You can just use enable auto configuration. You don't have to use the Spring Boot application that is doing class path scanning, turning the class into an @configuration class. You just need to enable auto configuration, use this @import thing, and that will be taken in account, supported by Spring IoT, etc. And you can even use it in libraries, just using @import on any configuration class, and that will be automatically discovered by any kind of Spring application. So again, the integration with existing Spring Boot application or libraries will be much more powerful. There is another area where I wanted to improve the runtime efficiency of Kotlin application. It's Kotlin Reflection. You may know that I'm very passionate about making Spring application more efficient. I have been working a lot on the GraalVM support, on Project Laden. And yeah, something has always puzzled me. It's the cost of Kotlin Reflect. I have done some measurements compared to a Java application, a Kotlin application that has Kotlin Reflect because it is required to provide the features that we need, increase the startup time by around 15% and the memory consumption by around 20%. And this is mostly due because Kotlin Reflect is based on some former code coming from the Kotlin 1 compiler, and a compiler is not really designed to be used at runtime, okay? So, and nowadays there is better foundation in Kotlin 2 to use that. And so we did an experiment with the Kotlin team. We replaced the Kotlin Reflect, a library that is currently used, by a more lightweight variant that is based on Kotlin JVM metadata library that is first class supported on Kotlin 2. And we saw that basically the overhead reduced dramatically, like less than 2% for the startup time and almost no increase in terms of memory consumption. So basically there is this issue. Alexander Rudeloff from the Kotlin team is working on re-implementing completely Kotlin Reflect in order to use this Kotlin metadata JVM library that is already supported for Android use case, etc. It's based on very new Kotlin 2 based infrastructure, much faster. The goal is to not break too much or at all the API. I'm not sure what will be the outcome, but the goal is basically you will have the same API on Kotlin Reflect, so that means Spring will benefit of it, Jackson support, all the ecosystem will basically have much less performance impact when we are using Kotlin Reflect. And I think that's pretty exciting. It's not yet available. It won't be, I think, available for Spring Boot 4.0, but I expect it to be available in a former Spring Boot 4.x release. Not sure if that will be Kotlin 2.3, 2.4, 2.5. Maybe talk to Alexander to ask him. But this is an ongoing work that we appreciate because that will remove the biggest efficiency impact, negative impact that Kotlin had. And I think that's pretty cool to have the same performance on both Java and Kotlin. But in fact, it should be possible to write even faster Spring Boot application with Kotlin than in Java because we have features like value classes, etc. But there is a little problem. The problem is that currently Kotlin Reflect do not provide the right API to Spring to do that. So we have to do terrible things like boxing parameters and unbox return values. It introduced some overhead. And so in practice, the Kotlin code that is using inline value classes will be slower than the Java equivalent. I mean, that Java code that is not using that because that feature is not yet available on Java. And so the second improvement that the Spring team have been asking to the Kotlin team, who has not refused, so I need to be sure that they do that, but we are basically discussing, is provide the right API that for Java framework, it will allow to use basically inline value classes, not data classes, excuse me, previously, inline value classes more efficiently. Okay, it's not specific for Kotlin, but basically we have ways to optimize Kotlin application on the JVM with CDS and IoT cache. You may be aware that GraalVM native images allow you to start your application faster. There is first-class support in Spring. It's super cool, instant startup, very low memory consumption, but it's not easy to leverage in real project because first, the build time is very slow. And second, there is compatibility issues because you need to provide ints, metadata in order to basically support libraries that are based on reflection, proxies, etc. Spring does a pretty good job to configure that automatically, but in practice, when you are adding your own dependencies, you will likely need to add some stuff, and combined with the slow feedback loop, developer experience is not that great. So the goal is to say, GraalVM is super cool. You can write very fast Kotlin Spring Boot microservices with it, but we need something for the 90% of application which will not be able to leverage it. And so we have been introducing first-class support for CDS and IoT cache in Spring, which are technologies. So CDS is class data sharing. It's a pretty old technology, but we can leverage the latest incarnation in Java 17 and 21 to provide better performance. So the principle is that you are going to do a training run of your Spring Boot application. This is going to create a cache, and this cache will be used to start your application faster, consume less memory, and potentially later make the warm-up faster to reach peak performance in just a few seconds. So it's a lot of manual steps, so we provide support in build packs in order to do that with just a flag. So just by enabling a flag, build pack is the technology that allows to create container images by default with Spring. If you want to do it with Dockerfile, it's perfectly fine. We are documenting that into the Spring Boot documentation, so just go there and you can use CDS with Dockerfile. But I think it's pretty cool to provide a developer experience where you enable a flag and basically Build Pack and Spring Boot are going to build your application, do the training run automatically, ship the CDS cache within your container image, so you have a self-contained artifact that you can deploy on any platform, and it will use this cache automatically when you are going to deploy, to run this application. And the good thing is that CDS is going to be superseded by AOT cache. AOT cache is basically the successor of CDS, created via the project Leiden, which is a kind of effort to improve the efficiency of the JVM. It has been shipped already in Java 24, so we are not talking about some experimental technology that will be available in 3 years. We are talking about something that you can already use today with Java 24, and that we will be able to use in an improved version with Java 25, which is the next LTS to be released in September. And the results are pretty cool because keep in mind that CDS and AOT cache have very few side effects. So it's not like native where you need to do huge effort to support that. It's pretty easy to leverage. And so you can see in those data points that with CDS or AOT cache provided in Java 24, we are around 2x faster startup time for your Spring Boot application, including in production on real servers. Of course, that will vary depending on your servers and application, but that's a pretty consistent improvement that we see. And with the upcoming improvements that are coming in future Java version, and some of those improvements are going to be shipped as early as Java 25, so again, pretty aggressive timeline. You are going to enable 4x improvements, not with 25, but with upcoming versions. You can also lower the memory consumption. So here the gains are less dramatic than with native image, but we can shave around 20% of the memory consumption of your application. So 20% of memory used less for your infrastructure. So this is more memory for your heap, and so you will be able to have faster performance even on smaller machines. And the third aspect, and I really like that one, is that those technologies, if you are not doing a training run in an isolated environment, but let's say you are getting the profiling data from the production directly, okay, and you use that to create the cache, you then are able to improve significantly the warm-up of your application. I call that express warm-up. So basically with express warm-up, you see this blue line, it's the throughput request per second that we have with Pet Clinic with a regular JIT, Java 24, nothing special. The red line is when we are enabling the feature that is targeted for Java 25. It's AOT profiling. So we just get the profiling data from the production, and we use that to speed up the warm-up. You can see that with the red line, we are able to speed up significantly the warm-up. And the yellow line is basically AOT profiling plus code compilation. So here, we are even getting the native code that has been compiled by the JIT from production, and we are feeding our AOT cache mechanism with that in order to have a super express warm-up. You will maybe notice that there is a small gap in terms of peak performance plateau. This is going to be fixed by the Java platform team. In theory, this is a current limitation, but I have good hope that at least for the AOT profiling feature that will be provided in Java 25, we will get the same level of performance. And I think what is cool is that with AOT cache and Project Leiden work, this is the beginning of this is the continuation of CDS, but this is just the first version of AOT cache. And like Java 25 is going to improve what we have in Java 24, in Java 26, 27, 28, etc., it's going to be improved. So that's a safe bet for the future, because if you leverage AOT cache today, you will just benefit of increased improvements as you just upgrade Java version with your Kotlin code. So I think that's pretty cool, and you can apply that even on legacy project, etc. So it's not something super fancy in demos. It's something that you can really make actionable in your real work with your real application without too much pain. Okay, now Spring AI. So we have been announcing Spring AI 1.0 just 2 days ago, I think, or just yesterday, I don't remember. It provides Kotlin support. It's not yet perfect, like it does not provide null safety yet, so we need to have Spring AI based on Spring Framework 7 and Spring Boot 4 to get the full null safety, but we already get some pretty cool Kotlin support. For example, we have this structure output API that is provided by OpenAI, and that allows to basically match the result with a JSON schema that will be typically created from your model classes. So if you are doing that from Java, the code is not super readable because you have to add all those JSON properties to say this property is mandatory, this property is optional, etc. That's not super cool. So there is Kotlin support in Spring AI to basically directly infer that from the nullability of your Kotlin code, of the Kotlin properties, and so that makes the code more readable. But there was still a problem because, you know, with Kotlin 1.x, we have to specify, and that's true for bin validation, Jackson, and a few other popular annotation-based library. You need to specify the use site of the annotation in Kotlin because otherwise, in the generated bytecode, the annotation will just be on the parameter and not on the field, and those framework will lose that information. Every newcomer in Kotlin gets hit by that. Why my add.json property or my bin validation annotation is not taken in account? That's a disaster. What is pretty cool is that with Kotlin 2.2, with this experimental -x annotation default target equals param property, but I hope, and I think that will become the default at some point, you don't need to be that, to do that. You can just use add.json property, and there is a new default policy to basically translate Kotlin code to bytecode, and here, that will just apply the annotation both to the parameter and the field, and so the Java-based framework will be happy, and that works for bin validation and others, and newcomers will stop crying on Stack Overflow why my annotation is not taken in account. So I really like that one. I don't know when that will be the default, but I will push for that, and thanks for the Kotlin team for solving those real developer experience issue. The interop with the JVM and Java is already pretty cool, but with that kind of thing, I think we are reaching a new level, and that's promising. You can go to the Kotlin website, who is pretty up to date because they already provide a Spring AI-based tutorial in order to explain how to use it with Kotlin. So just go to your regular Kotlin documentation. There is a Spring AI tutorial, and pretty cool to see that they are providing that the same day, basically, than Spring AI 1.0 is released. So this is cool to have those new features, but I felt the need to introduce a new reference application because, I mean, we have a Kotlin tutorial in the Spring website where we are using Spring Data GPA, and I think this is Mustache, but some use Teamleaf and other templating system. To be clear, it's perfectly fine if you developed a Kotlin Spring Boot application with the same kind of technology that you are using on Java side, and it's also for that capability that Kotlin is successful. You can just take your regular Java-oriented frameworks and libraries, etc., and just use Kotlin, and that will work. But I thought it was interesting to maybe explore a more Kotlin-ish way to build Spring application. And so I need to improve a bit the code base because that was kind of developed in 2 days. But I would like to introduce Pet Clinic with a K instead of a C. Pet Clinic is our regular, typical example application in Java. And I wanted to introduce a more Kotlin-oriented reference version, and this is what we are going to discover today. It's not perfect, but it's a way to share the area that I would like to explore with this collaboration with the Kotlin team. So the architecture is the following. We are, of course, going to use Kotlin everywhere, but we are also going to use Kotlin in the front end and share code between backend and front end. My goal here is not to create a rich internet application with everything for the front end on Kotlin side. It's just to keep what we do usually, like we develop a backend application, but instead of using HTMX or basically JavaScript or TypeScript, I'm going to use Kotlin WASM for the teeny part of front end that I need in order to avoid to pay the cost to learn all the JavaScript ecosystem and suffer. And I mean, it's a key Kotlin superpower that we are not using enough, in my opinion. And if we want to increase the attractiveness of using Kotlin for server-side workload, I think we need, I mean, Kotlin is the leader on Android side. It's used with Compose, with every platform possible. We are really missing that opportunity on server side, and I think we can and we should leverage that more. So in my sample application, I'm using shared code with Kotlin multi-platform for template rendering, validation, DTOs. The rest is implemented with Spring Boot 4, a preview, so things may change for the backend. We are going to use Kotlin WASM for the front end, and we are going to have a microservices that is compiled with GraalVM native images running Spring AI. So let's see basically a demo. So we have our project that contain 4 modules, front-end, back-end, shared, and AI. We have previously built everything, so I'm just showing the Docker Compose file that I'm using that will run a Postgres database, that will run our backend, that is using the JVM with CDS optimization with the build pack thing. And we are also, it's a Spring Boot 4 application, and a Spring Boot 3.5 application because Spring AI is not yet compatible with Spring Boot 4 snapshots. And we are going to run those things with Docker locally. And we are going to see a quick demo of the application. So first, it starts pretty fast. So you can see that our CDS plus JVM-based application starts in 700 milliseconds. Our GraalVM-based microservices start in 50 milliseconds, so pretty cool. The application itself, I'm not a designer, okay? So it's a regular pet clinic, just with a few changes you are going to see. So it looks like the same pet clinic, just it is implemented very differently. We are going to see the detail. You can find owners. If you search something here, it's Kotlin WASM, which is updating the page. We are not reloading everything. You can update things. It's just a regular Spring pet clinic with just an additional feature that I'm going to show. You have validation, and the same validation is used on backend and frontend. So here, if I'm basically doing invalid stuff, I have an alert that say invalid name, invalid number of telephone, and I'm going to share that code between frontend and backend. So I can edit an owner. Okay, and I can add a new pet. So here I have added a new feature, which is the capability to basically generate an image for the new pet with an image prompt. So I'm calling it Pupus. That's a very famous, popular name for pets in France. And we are going to say, basically, a mysterious dog eating pasta, because we want to have a bit of fun with OpenAI generating a crazy picture. So we add it. Basically, our application is going to contact the microservices that will contact OpenAI. Take a bit of time, because OpenAI need to generate this incredible picture. And when that's done, we are going to see the new picture that has been generated in Pet Clinic, and we can see, what can we see? Yeah, clearly it's a mysterious dog eating pasta, no problem, thanks. Thanks AI. So we are going to see a bit the code, because again, I'm not a designer, so the design of the application is not incredible. If you want to collaborate with me to make it more fancy, feel free to ping me. We are going to see the backend developed with a preview of Spring Boot 4 and sharing code with Kotlin multi-platform. So we have our backend project, which is using a preview, a snapshot version of Spring Framework 7 and Spring Boot 4. We are declaring a bunch of plugins, including the Kotlin serialization one, because we are going to use Kotlin serialization for serialization. We are using Java 24 because we want to enable virtual thread by default, and I recommend you to enable virtual thread. That improves the scalability, that works pretty well. And Java 24 solves the thread pinning issue that we had previously with this technology, so virtual thread plus Java 24 works pretty well together. We are defining a bunch of dependencies, so you can see that we have some Spring Boot Starter, Spring Web, Spring Data JDBC, and Cache, and we have also some Kotlin dependencies, Kotlin HTML for the template rendering, and Conform, for example, for the validation that we will apply on both server-side and front-end, so it's some multi-platform libraries. Here, we are defining that we copy what Kotlin WASM is going to generate in the /static directory of Spring Boot. So we are going to serve the JS and WASM files that are going to be generated by Kotlin WASM. And finally, we enable CDS and Spring IoT optimization in build pack with just 2 flags in order to benefit of those optimization by default and allow the fast startup that we have seen. If we go in our application class, that's a bit different than usual. We are just using @enable auto configuration. We are not using the regular Spring Boot application annotation because we don't need class path scanning and we don't need to make this class an @configuration. We can enable and use any kind of annotation-based annotation, so you can mix annotation-based and lambda-based and DSL-based programming models. And we are using this new @import capabilities to import the bin DSL that will be taken in account automatically. And yeah, this is going to basically allow to declare some bins. So here we are getting the image generator URL property. We are creating a REST client bin thanks to that. We are customizing the Spring Boot configuration with an HTTP message converter bin to just use string and Kotlin serialization JSON converter in order to disable all the other ones, so it's more efficient. And we are using some callable-based reference register bin invocation in order to register various routers that are using maybe the DSL that you already know, which allow to register some web endpoints. So here we are registering a slash endpoint that will basically produce an OK HTTP response that is using Kotlin HTML to render your application. And of course, it provides full autocomplete, etc., because this is just Kotlin code that allows you to generate your HTML templating. So this replaces Mustache, Teamleaf, this kind of technology. We are using some layout, some templates. So basically, here we are just injecting the content of the component inside basically the page structure. And this is on the shared code. So this code can be used to render the page on backend, but also I can reuse it to refresh the component on frontend if I have to handle some kind of fancy AJAX HTTP invocation on frontend. You can also inject some repositories, so the parameter of your callable references will be injected automatically by type. Here we are using Spring Data JDBC to implement the basically logic to get the data from the database. We are writing some HTML endpoints, but also some JSON one with Kotlin serialization JSON. So we are just leveraging the Kotlin multi-platform ecosystem within Spring. Here, I'm doing something a bit different. In a post endpoint, I'm getting the result from the form that I have submitted, and I'm doing the validation of my object using conform, which is a multi-platform library. Here, you can see that also we are doing that on a serializable class that I'm also shipping very close to that. And everything here is part of our shared module. So again, I can reuse that on frontend as well. And I can also test that one time, and basically my frontend and my backend will be covered. So I have written some unit tests in order to check the validation. So basically here, I'm writing some code that I can run either on JVM side or on WASM side to check that basically the validation of my business rules are OK. And I can also check that the templating rendering is correct. So basically, I'm injecting some fake data. I'm calling the rendering function, checking that the output is fine, and that's OK. So I think that's pretty cool to be able to mix Kotlin multi-platform capabilities with what Spring provides. We are now going to see the image generator with Spring AI. So this is a distinct application that is based on Spring Boot 3.5 because Spring AI is not yet compatible with basically Spring Boot 4. So we are using Spring Boot 3.5. We are using Java 24 as well because we want to have virtual thread support in the best way possible. We are going to define the Spring AI 1.0.0 BOM in order to set all the dependencies version. And we are using some starters, Spring AI starter, to provide support for OpenAI. Then we are using some libraries. And if we check the application, this one is just annotation-based, the regular way, nothing super different from usual. And we have some application properties to provide the open API key coming from the environment variable. We define the default image size that we want. And our controller is very simple. It's just a controller that takes as a variable path variable the prompt, pass it to OpenAI, generate an image, and return the URL of the generated image. And that's it. And this is basically the support that we use. And that allowed to generate some incredible picture like that one, which is honestly the best I could have. This was my first try, and I'm really fascinated by this dog eating pasta. It's clearly mysterious. Now, let's talk a bit about the front end. So my goal is not to create a rich internet application, etc. I just want to create a realistic application that is mainly rendered on server side, and that has some code where usually I need to basically pay the price to learn the JavaScript ecosystem. for the front end. So if we have a check to the front end module, this is using the Kotlin WASM plus the Kotlin multi-platform capabilities. So you can see the Kotlin multi-platform is declared, serialization as well. We are declaring the the WASM JS target to say we are targeting the browser with Kotlin WASM that is now supported by all the major browsers, including on mobile. And we are using a few dependencies like Kotlin serialization, Kotlin browser for the DOM access, and conform for the validation. And so in my main, again, nothing super complex. It's just that I want to avoid the price to learn all the JavaScript ecosystem. Here, I'm going to basically get, add an handler listener on the submit event of my form. I'm going to basically send a request using the fetch API that is exposed via Kotlin browser, get the result of the search, get the list of the owners, and directly, without reloading the page, basically render this template on front end and inject the content inside my list of owners using some DOM operation. So nothing super complex. The API can be improved, so you have created a bunch of issues on Kotlin X browser to improve that. We can also have some validation. So here we are just taking the result of a form submission, calling our validation logic that we are also using on server side to validate the inputs. And if there is an issue, like in my demo, I just provide an alert box and that's it. And otherwise, basically the request is sent properly to the backend. So Kotlin X HTML is cool, but I think we can do better. And I have a call for action for the Kotlin team. I have begun to talk with them about that. Compose is nice. Compose allows to target all the platform. I really understand the attractiveness of Compose for web, which is basically pixel-perfect rendering for your Compose app, and basically you have a canvas with a big WASM code, and everything is rendered pixel-perfect. That's okay, that's perfectly fine for a lot of use cases. But for public websites, I think that's not a good fit. I want to continue to use the DOM. I want to have basically the Vue.js or the React of the Kotlin ecosystem, and that's really missing. And so I think that basically if Compose HTML, which is a variant of Compose, you can have a code here that basically allow with some Compose plugins and syntax, you can declare HTML elements, etc. So it won't be pixel-perfect rendering. The goal is not that. The goal is to provide a first-class front-end framework that is suitable for public website where you need some small footprints, you want to keep the accessibility of HTML, etc. And so I think it's doable, and there is a very interesting framework named Cobweb, which is exploring that with Kotlin JS, and it's battery included, so it's not a good fit with Spring and Cater, but I think Cater and Spring and the Kotlin WASM team and the Kotlin team could basically team together, make this Compose HTML first class, support Kotlin WASM targets, support rendering initially on server side and basically augmentation on front end when the page is loaded, provide the nice Compose auto-reloading feature, provide footprint optimization because this will be used only if the footprint is tiny. But I think Kotlin WASM and Compose has the technical potential to achieve that. So my hope is that maybe not next year, but a bit later, we would be able to show this kind and to evolve this pet clinic variant in order to use some evolution of Compose HTML. I think Cater could benefit of that, Spring could benefit of that, and I think that could really make a difference where Kotlin, it's not just a better language compared to Java that has evolved, and I think it's not enough to be a better language to increase Kotlin market share. I think we need some strategic advantage here, and Kotlin has a lot to provide, basically to provide a very nice front-end experience, and I think that would be a game changer. Speaking about the short-term future, Spring Boot 4.0 will be released in November, so feel free to test release candidates, milestones. We are working hard on adding null safety everywhere. Yeah, we will appreciate your feedback, and you will begin to consume those improvements in Spring Boot 4.0. Hopefully, the better, more efficient reflection will come a bit later. And we work together closely with the Kotlin team in order to reach a new level of developer efficiency and experience with both Spring and Kotlin. Thank you for your attention. Don't forget to vote, and I'm available to answer to your questions. Thanks.